Hello guys, we are back with another lead code problem and we are continuing our series of recursion and backtracking. So let's see the today's problem. And today's problem is combination sum. It's a must do question. It's a highly like and it's make the foundation of recursion. You understand recursion more clearly. So let's dive into the question. So in this question you have given an array of a distinct integers and the name is the array is candidate and you have given a target integer and the integer name is target in that case. And what you are going to do, you are going to make a list of all unique combinations of these candidates where the chosen number sums to be equal to target, and you can return the combination in any order. So here is a one more thing. You can pick the same number as unlimited number of times. Okay, and two combination are can be classified into the unique category if the frequency of any of them is different. Okay, it's a one more point you have to notice this thing. Okay, so let's understand the question. What's actually question asked with this example one. It's make you it's clear all the concept what's actually question ask. So you have a given and candidates array this 2 3 6 7, this 4 element is present in that, and you have to reaches to this target. So in this case target is 7. So if the total you pick some element in which in this candidate, and you if you are able to make this 7 target and total sum equal to 7, so it's your one of the combination. So if you want to make this 7, if you pick this 7 one time and it's equal to this target, so what is actually mean, it's your one of the combination. So you see in the output, yeah, there is a one of the combination is present, this 7, and one of the other combination is 2. I'll take this 2 times and pick this 3 one time, and 2 plus 2 4 plus 3 7. So the total summation of these elements are 7, so it's one of the combination. So basically, and there is only two possible combination is there. So that's I'll return this vector of vector. So that's pretty much about the question actually, and we can say we have to return this 2D vector. So how can we do that? That was a biggest issue. If we try to solve this problem by manually, we don't know about how many times I have to take this 2, how many number of time frequency I'll take this 3, how many number of time I pick this 6 or 7. I don't know. If I try to do manually, it takes a lot of time and it's a highly complicated. We can't do with ourselves to make creating a loop and loop for loops and try to find out all the combination. It's a totally hectic and highly complex. So we know one thing we can't do with the using the for loops. So how can we approach this question? We can do this question using the for loop, but it's complex. So how can I approach these questions? So in such type of question, if we observe one thing, if we saw this question and observe one thing, we have a choices. We can pick this 2 or not. Either I pick this 3 or not. There is a choice. There are choices is here. So whenever you have a choices, whenever you have a two choices, so it means there is something recursion. You can use the recursion, you can think of about in the direction of recursion. You can solve this problem by recursion, because if you see, you can you have given this big problem, you can divide it into sub problem, or you minimize this bigger problem into these sub problems. Okay, how can I do? If I pick these two, so if I pick this two, so my target will be 5. I need only 5. If I make this 5, so I can make this 7 too, because I uh, pick this two already. So what I do, actually I minimize, dividing my bigger problem into the sub problem. If I solve this problem for the uh, smaller sub problem, if I have an answer for the sub problems, so I can generate answer for the my bigger problem too. So that's my think of, and that's why I'll say it's we can do this, we can do by using recursion discussion. So let me just write the code and you can understand better what I actually want to say. So and so I'll just made a one vector. I'll just I'll declare it globally my answer variable, answer to the vector, because it's kind of easy for me to understand. It's my habit to make the answer vector globally whenever I work on the class. You can make into this function, but it's my habit to make my answer vector in globally into the class, or you can say public. So how can I solve this problem? Okay, so I what I want to do, I want to use my helper function. Let's name the helper function like solve, and I assume it. If you using the recursion, you have your one duty. You 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 have to not do everything by own. You have one of the friend, name its recursion, and you think of recursion can do anything what you want to assign that recursion. You have to do some manually things, and here I am just going to do manually things. You understand what I am actually want to uh, tell you. So let's try to complete this solve, then you understand little bit more. So I assume this solve function what actually does, it it generate all the combination and store into this answer. After all things done, what I'm going to do, I have to return these answers to the vector. So let's now think of how many parameters needed. I'll just pass it this candidates. So I'll copy it here. Oh, let me resize the id for better clearance. So I'll just pass it this one of these thing, and I'll pass it this target. So here I pass it. That's two parameter I pass it here because it needed, because I have to traverse this thing too, and I need it. And after that, what I actually, and I'll pass it the size of this. I'll just pass this size of the array dot size minus 1. A candidate dot size minus 1, it contains the last index value, last index. Okay, and this solve function what I actually do, I pass it one of the another vector. In this vector it store the temporary answer. So let's name it temp. You understand more confined when I complete my solve function, and that's it. What I actually do, I'll make it temp, it's an empty vector. I pass it here, and what actually this solve function does, it generate all the combinations and store into this ans, and I return store all ans. What's my duty? Only I have to return this ans, and that's it. I'm done with that. So now my one of the duty, I'll do the job. Now the turn of the recursion. And but for calling the recursion I have to do some manually work on this recursion function. So let's try to do this manually job. So one of the things, this solve function is a void type because I don't return anything from here. So that's why I made it as a return it's void. Let's call it solve, and it take the two parameter. Okay, it's take candidate and vector, so I'll copy it from here because for not writing much more. And let's change the name for our is because it's array and not a target. Let's name it target sum. It's easy for us. And another parameter is size, so I'll just write it. And is actually denoting the size current last index of the array. And my last parameter is a vector int temp. Let's name it temp. Okay, that's it. So I know this n is a zero base indexing. If this candidate size is less than -1 in anyhow, what I actually do, I'll just let me tell you what I'm actually want to do. I'm actually on this side and I have a choice. I pick this element or not. If I pick this element, so I can again pick it or not. So that's two option for me. If I don't pick it, so I move here. Here I have a two choice. Either I pick this element or not. Let's say I don't pick this element, so I'm come to here. And after coming here, I have a two option. Either I pick this element or not. Let's say I'm not interested to pick this element, so I come here again. And either I pick this element or not. Let's say I don't want to pick this element. So after that, what? It's pointing to somewhere -1. So it's a invalid. So in that case, for not getting invalid cases, so here what I do, if my n is less than 0, in that case what I'm going to do, I've simply written it from here. That's one of the thing. Let's say, let me make more thing. If let's say I'll just pick this element and I'll complete this target. So what it actually mean, so my target sum will be 0 after that picking this element and subtracting from this targets. So it's 0 whenever my target sum is equal to 0. In that case, what I understand, and let's mention it above. Let's my target sum equal to 0. What it actually mean? It means, what it actually mean? Okay, let's complete for the choices, then after commit here. So at every index, I'm here, I have a two choices. Either I pick this element or not pick this element. Do you agree? And but if this, let's say this is not 7, is this 9, and you have target 7, 9 is greater than 7. So we know we can't pick this 9 because 9 is greater than 7. So in that case, I didn't want to pick this element. I'll just try to pick another element. So this is one of the case. Let's write for this case. If my array n is greater than my targets, in that case what I'm going to do, I don't want to pick this element. This array, I don't want to pick this element. So I'll shift it my, if let's say it's a 9, so I know I can't pick this element, so I'll just move ahead. I'll make my current index pointer here. So I move my n is my index, so I'll move my index shift to the left, so it's -1 and -1. And after that, what I go, that's it. Because if my array and my current index value is greater than my target sum, so I can't pick this element. Otherwise, if it less than or equal to, in that case I have two choices. either I pick this element, either I pick this element and minus 1 temp, either I pick this element or either I sorry, either I left this element, sorry for little bit silly mistake, or either I pick this element. If I want to pick this element, so my first duty, how can I pick this element? If I add this element into my temporary vector, so it means I'll pick this element. So I just add into my this temporary vector, it means I pick this element and push into my temporary vector. Now my duty, and I write it function this or this. If I add this both of them, so it's mean I pick this element, or this alone, it means I left the element. So for picking the element, what I could, if I pick this element, I have to subtract this picking element. So it's a array n. So I subtract it from here. So it means I pick this element, and I didn't decrease my n here, because we have given we can pick unlimited number of times. So that's why it may be possible if I pick this, let's say this case of 2, I pick this 2 one time, but I needed one more 2, so that's why I'll just pick 2 times. So that's why I didn't decrease the size. Yeah, that's it. And and let's say I'll read, so it's completed. Let's complete our TS. If our target sum is equal to 0, what does it actually mean? Let's think about that. This case, I'll pick this 3 one time. So my required target is now 4. So I'm coming here. I'll pick this 2. So now my required target is 2. And I'm again pick this 2. Now my required target is 0. But it's my one of the unique combination. So I have to add into the answer vector. So that shows I have to add it into my answer vector. What should I add this time? And after that, it's my answer. So I have to return it from here. So that's pretty much my solve function, and that's it. Let's run this code, guys. And it's accepted. Let's submit this code, guys. Yeah, that is accepted. Let me show you. So if you have any doubt, let me know in the comment section. I resolve your doubt as soon as possible. Until then, keep grinding, guys.